students, today we will solve the numericals or the questions you can say based on the combination of errors, and now we will take the function multiplication and division. Ab say for example, now we are taking the first question for the day. Say the distance covered by a body is given by 100 plus minus 1 meter and time taken for the covering the distance is 5 plus minus 0.2 seconds, and the question is saying ki find the velocity with proper error limits. So we will calculate the velocity by the normal formula like velocity is distance upon time, or in this case we can say displacement upon time. That way so we get 20 meter per second. Now you know, if you see this formula, so if we apply the formula of combination of, or you can say the multiplication or the division one, then we have delta V upon V is delta D upon D plus delta T upon T, because we are calculating the maximum possible error. So if we take delta V on one side, then this V will come to this side. So on substituting the values we get, now absolute error in displacement is 1. So we get 1 upon 100. Similarly for time is 0.2, so 0.2 upon 5 within bracket, then into 20. So after solving we get value as 1 meter per second. So our answer will be 20 plus minus 1 meter per second. This is the, you can say, the velocity with proper error limits. Now we have taken another formula. Say our new physical quantity is there, which is Z. It is given by A power 2, B power 3 by 4, C power 3 by 5 and D power 1 by 4. Now two terms are in the numerator and remaining two are there in the denominator. Question is saying ki find the percentage error in the measurement or the calculated value of Z if the percentage error in A, B, C and D are 1%, 2%, 5% and 4% respectively. You know, for this type of question we have discussed the formula ki whatever is the power, that will come like a coefficient. So in this case we can say ki percentage error in Z will be 2 into percentage error in A plus 3 upon 4 into percentage error in B plus 3 upon 5 into percentage error in C plus 1 upon 4 into percentage error in D. Now we substitute the values. So we get 2 into 1 plus 3 upon 4 into 2 plus 3 upon 5 into 5 plus 1 upon 4 into 4. And after solving we get 7.5%. Now next, अब say for example the question is saying कि a body is moving and the percentage error in the measurement of mass is 2% and velocity is 5% respectively. Then find the percentage error in the calculated value of its kinetic energy. Now you know kinetic energy is given by half mv square. So if you see in this formula, half, that is a constant, it is not the measured quantity. So the percentage error or the absolute error, whatever is there, it will be there only in the measured quantity, means in mass and velocity, not in this constant half. So whenever we have to calculate the percentage error in this type of questions, then we ignore this constant term, means we don't consider the constant term involved in the formula. So we simply take ki percentage error in kinetic energy is percentage error in mass plus 2 times percentage error in velocity. So on substituting the value we get 12%. So just keep in mind that this sort of constant, if half, 3 by 4, 1 by 8, any constant is there in this sort of formula, then ignore that constant or don't substitute the value of that constant in the formula while calculating the percentage error. Now next question means the last question for the day we are taking. So two values of resistances are R1 is 4 plus minus 0.1 ohm and R2 is 6 plus minus 0.2 ohm. The question is saying express the final answer or the effective resistance in series and parallel combination with proper error limits. So now series, so you know the formula is simple, R1 plus R2. So we say 4 plus minus 0.1 plus 6 plus minus 0.2, the errors are added. So we get 10 plus minus 0.3 ohm. Now for parallel, so we are knowing that parallel combination, the formula is given by 1 upon R is 1 upon R1 plus 1 upon R2. So if we take the LCM and solve it, then we get R parallel will be R1 into R2 upon R1 plus R2. So we calculate the value of effective resistance in parallel first. So that value we get after solving कि R1 is 4 upon this. So we get 2.4 ohm. Ab now you know that in some books they had given the formula of fractional error and then by solving the partial differentiation method. So we are not following that formula. We are simply using the method which we have done in the class. Ki means now in this case you can take ki RP means the final quantity R is product of three quantities R1, R2 and R1 plus R2, and R1 plus R2 is there in denominator. So whether the quantity is there in numerator or denominator, we always add the values because we have to calculate the maximum possible error. So we get delta Rp upon Rp means fractional error in parallel resistance will be delta R1 upon R1 plus delta R2 upon R2 plus delta R1 plus R2, that is the third quantity, upon R1 plus R2. So substitute the values, so we get 0.1 upon 4 plus 0.2 upon 6 plus 0.3 upon 10. So after solving, we can calculate the value as delta Rp will be, take Rp on this side, 0.1 upon 4 plus 0.2 upon 6 plus 0.3 upon 10, overall bracket into 2.4. So after solving, we get 0.025 plus 0.033 plus 0.03 into 2.4, or we get 0.2112. So because all the values are till first decimal place, we write it as 0.2 ohm. So our answer will be 2.4 plus minus 0.2 ohm. Now if the similar question is there, they are not saying to express the answer in standard form. They are saying to find the percentage error in series and parallel. Then in that case, percentage error in series will be 0.3 upon 10 means 3%, because we multiply the fractional error by 100 for calculating the percentage error. Similarly, for percentage error in Rp will be 0.088 into 100 means 8.8%. Now that's all for the day. Revise the topics. In case of any problem, you can clarify your doubts in the class group.